Okay, it's 8:02. We'll go ahead and get started. First of all, we did have a attendance error. Everybody in here remembers that I took attendance last week because I even asked y'all. I said right at the, I said 2 or 3 things during when I was taking attendance, and I knew I took attendance because one thing is when I got to the Robinsons, I said I know everybody except Mahogany. And I knew I took attendance, but evidently either I hit the submit button and it didn't submit, or I didn't hit the submit button and it didn't submit. So, of course, that sends a message to student records that says that nobody was here on that day. That Left Behind plane just vanished, and everybody in the class was just vaporized. Okay? That's what it sends them. Then they send y'all an email that says that you were vaporized and that you did not exist that day. And then you email me saying that you did not exist that day. Okay? I'm not trying to overemphasize. I'm just trying to tell you that if you were here and I took attendance, then there must be some kind of what? Error somewhere. Okay? No need to get all hammy, all right? I only got 15 out of 30 emails. 15. Of course, I did not respond to them because there's no use in doing it because I was going to address it this morning. I will take roll twice this after class, okay? One will be from the other day, which I know all the Robinsons were here, but the rest of y'all I will take today also. So I apologize for that. So let's get started. Turn to page 6 or 5, and we will start talking about what definitions are important, what is important in the book in chapters 1 and 2. You should have already read chapters 1 and 2. You should already be done with chapters 1 and 2. Homework, you should be working on it. Not that big of a deal. But we will talk about what's important and what's not. Now, you can go about doing this 2 different ways. You can go about and highlight what's in your book, or you can write it on index cards, or you can write it in notes, or you can just sit and listen. I don't care. Okay? But I would suggest that you do make some kind of mark beside the problems or beside the terms that I say are important, because therefore, when the test comes about, you'll know what's important and you won't have to reread the whole chapter. All right. What are we doing in statistics? Well, when we are talking about statistics, let me just go ahead and give you a little synopsis of what we're doing. We are trying to predict the future, basically. Okay? Now, of course, we cannot predict the future, and we'll get to that when we talk about probability. And that's what probability is. Okay? In order to get to that point, we have to have some kind of math, or we have to have some kind of pattern, or we have to have some kind of evidence in order to get to this point. It's kind of like, I give this scenario every time we talk about probability. Have you ever gotten behind a little old lady on a very long highway, 2-lane highway, and they're going 35 miles an hour? I'd like to use the analogy of Wild Hog Road. Everybody in here knows where Wild Hog Road is. It's 187, goes up to Pendleton. It's out here past the double bridge. Garrett's little store, turn right, and you go to Pendleton. It's 2-lane road. It's about 6-8 miles long. Okay? If you're in if you got to be at 8 o'clock class in Pendleton, it takes 16 minutes to get from 24 Bilo to Pendleton. 16 minutes if you drive moderately. Okay, so you it's at 7:30 and you got to get to Pendleton by 8 o'clock. And if you get on Wild Hog Road, you're going to get behind the little old lady or you're going to get behind the school bus. Alright? Now, school bus ain't that big of a deal. But the little old lady is, because the little old lady's going to go slower than the school bus. And you're going to get behind that little old lady. Guess which way she's going to turn when you get to the end of Pendleton? The end of Wild Hog Road. You can either turn left and go to Pendleton, or you can turn right and go to Sandy Springs. You're turning left. Which way do you think the little old lady's going to turn? How do you know that? Because of experience, because of you're in a hurry, because of Murphy's Law, and because you know that she's going to stay in front of you because you're in a hurry. All right? You're predicting the future, even though the 50s shots, Sandy Springs, you know she's going to turn left, and she does, because of your past experiences. So, what you do is you mentally record that, and then next time you get on another 2-lane road, and you in a hurry, and you are behind a little old lady, you're going to know that, okay, I'm going to turn on my right blinker, that way she'll turn right, and then I'm turning left. Okay? Anyway, you use those experiences and those things that you've done in the past to predict the future. Now, of course, you cannot predict the future as far as telling when somebody's going to die or anything like that. That's not. But you can use math to tell if somebody that does a lot of drinking and driving, you can ascertain that they ain't going to live very long. Why? Because one day, those cow horns will what? They will hook. And somebody that does a lot of drinking and driving, one day they're going to die. Or they're going to get somebody killed, one or two. But that's because we're taking those statistics here and we're changing them into a prediction. Alright? So, in order to be able to do probability, you've got to be able to do statistics. And statistics is what this is up here. This is statistics. I was writing. Was I not writing? I thought I was. This thing is not what it needs to be. Statistics is basically the gathering, calculating, and evaluating numbers. Now, of course, we're going to turn to the definition in the book now. No sneezing in class. All right. Statistics is the science of planning, studies, and experience, obtaining data, and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusion upon that data. Okay? Gathering, evaluating, and interpreting. Alright? That's what statistics is. Data, that's what you collect. Population. Population is the big set that you're evaluating, and the sample is the smaller set. If Tri-County Tech students are population, then Anderson campus would be a sample. If Anderson campus is the population, then this classroom, this class right here would be a sample. The sample is always the smaller set. I'm not going to worry about census. Census is not that important. The census is something that we take all the time, every what, 10 years? But I'm not going to worry about that because that's not detrimental to you understanding what statistics is. Okay, so there's your first set of definitions that's important. 4 definitions out of 5. Data, statistics, population, and sample. So you need to mark those 4. Y'all sickly bunch. Drink more dang old juice. And yes, we're going to move around because I'm not going to make you memorize the whole book. I'm going to pick out the parts that's important so we can move on to the math. All right, make a note about page 11. Make sure that you review fractions, decimals, and percent. Make sure you can switch from a fraction to a decimal. Make sure you can switch from a decimal to a fraction, or a decimal to a percent, or a fraction to a percent. Make sure you can, do that. Make a note of that. That's on top of page 11. There is a fan that has got a bad bearing in it or something. It sounds like a cricket. Y'all hear it? Driving me bananas. But anyway, I think we ought to call off class today because of it. What do y'all think? Yes. Yep. I figured y'all would agree. Bunch of losers. All y'all want to do is quit. All right, we're in 1.3, types of data. See, I told you this would go quick. All right, two very important terms, parameter and statistic. Parameter goes in population. Parameter, population, let's start with P. And statistic goes with sample. Now, you would think that this is something that is real detrimental because they got it in an orange box or a yellow box or whatever color, manila or whatever color you say that is, khaki. But it's not that big of a deal. Let me show you let me fix that calibration first. I'm going to show you what what parameter and statistic is, and then you'll understand it a little bit better. All right. In probability and statistics, there's two sets. There is the sample and there is the population. Now, one thing about the population that most of the time rings true is that the population is usually too big for us to worry about. It's usually too big and too costly to, do the statistics on or the probability studies or whatever the case may be. So, what do we rely on to predict for the population? We rely on the sample. We rely on the sample to predict for the population because it's too big and too costly for us to do that. Now, for students to understand which one that we're dealing with, when we're talking about formulas, we're going to have formulas for the mean, and we're going to have formulas for the standard deviation. Over here, the same thing. Okay, they're the same formulas. Just about the same formulas. Except, when you're dealing with a sample, you're going to be using what? Statistics. Now, this is not the same word as the statistics that we had a while ago. The statistics we had a while ago was the gathering of data. All right, it's kind of a big word. And then this is a small word that says that if you are dealing with a sample, your mean is going to be X bar, and your standard deviation is going to be S. These two guys right here are the statistics. In other words, I hate it. I have to spend this time because it's two words meaning the same thing, or different meanings. Same word, different meanings. The first word, statistics, means that the gathering of data. The second word, statistic, means that you're dealing with X bar and S, which means that if you see these two variables on a test, on a report, on anything, you know that you're dealing with what? The sample. That's all it means. It's an indicator. So if you're sitting in a meeting, and whether you're a department head or a division chair or whatever, floor manager, and you're going through a presentation or you're reading through a presentation and you see that X bar or S, you know that it's dealing with the population. That's what that means. Same. If you see these two guys, mu, which I usually draw Bass-Ackards, and omega, or not omega, sigma, if you see those two things, then what are you dealing with? You're dealing with population, and these are parameters. So, what's important about these two words? They're indicators. Like I said, the best way for you to understand what these two things mean is if you're sitting in a meeting in your career, 5 or 6 years down the road here, and you're reading and you're reading and you're reading, or the person's presenting and you're reading along with the presentation on PowerPoint or whatever, and you see X bar or you see S, and the S is usually going to be italicized. Then you automatically know, okay, well, this is dealing with the sample. And if you read along the presentation and you see these two guys, you automatically know that we're dealing with what? Population. Capiche? That's all it means. Nothing big. You see those two, it means sample. You see these two, it means population. The formulas are the same. Okay. Now, if you go back to is a numerical measurement describing some characteristic of a population? Is a numerical measurement describing some characteristic of a sample? That definition means that hopefully you won't be ignorant in a meeting and mismatch the two and not know. That's what it means. Know the difference. Okay? This is a test question right here. This is a test question. You bet your bottom dollar it's going to be on the test. Qualitative and quantitative. And if you've had probability and statistics before, you know the difference between the two. Qualitative consists of numbers. I'm sorry, quantity. Have you ever heard of the saying quality, not what? What does that mean?
Like how good something is versus how much there is of something?
Exactly. Quality, not quantity. You see this a lot in production. Think about a candy making business. How does a candy making business start off? Usually starts off with mom and dad or family or somebody. You ever seen a commercial where the woman puts together her toffee business from her mother's recipe? All right, it's a legalzoom.com or one of those. But she's saying, I started this business off with my mother's toffee recipe. Mostly all of your big productions start off what? Start off small. And when they started off small, they put out a good product, but they didn't what? They didn't put out a lot, did they? And then they go through a transition, and then they become this big company, and they put out a lot, but they don't generally put out what? As good as product as when it was Mama's recipe. Think about it in your hamburger joints. Think about it, think about the first McDonald's. Do you think the first McDonald's tasted like what we have right down here on Whitehall? No. Probably tasted like a Hardee's. I'm sorry, I shouldn't have said that. One of the big Hardee's burgers, it was real good. It tasted like your backyard burger, but then it got kind of what? It got famous, and it got making money, and then the quality diminished, but the quantity what? Increased. We went over 3 test questions, so you won't fail. Quality and quantity. Make sure you know the difference between the two. Quantity. God, now she's just making all kind of noises. Quantity. That means numbers. And qualitative means blonde, brunette, redhead. Brown hair. Brown eyes, blue eyes, green eyes. Blue jeans or khakis. If you're taking a survey in the classroom, how many people are above 200 pounds? Well, that's quantitative. How many people have brown eyes? That's qualitative. Okay, see the difference between the two? All right, that's what you need to know. Make sure you know an example. They give you some examples in the reading, so make sure you read them. I think they give you a couple of examples. So that's all I need you to do is make sure you know the difference between the two. Now, this one I spend a little bit of extra time on because a lot of people don't know the difference between discrete and continuous. If I was to ask you right now, if I was to send out a piece of paper or tell you to get out a piece of paper right now and tell you what is the meaning of discrete data and what is the meaning of continuous data, and you write down your definitions, half of you wouldn't even write down anything because you have no idea. And half of you would take the swag. What's the swag? Simple, wild attitude, yes. Swag, simple, wild, yes. And some of you would actually probably know it from a class that you've had in the past, and you've actually remembered something out of that class. All right, so discrete and continuous. Well, first of all, I'm going to start with rational and irrational. Another word that if I asked you to write a definition of, half of you would not be able to. Half of you would guess, and then the rest, a quarter of the class, maybe a quarter or less, would actually get it halfway right. What is rational? Anybody give me a layman's term definition? No, it doesn't have to be mathematical, just a number that is what? And irrational would be a number that is not. Predictable. Predictable. I can't spell. Predictable. What in the world is he talking about? What is predictable? Well, let's do a couple. Why are all these predictable? These are all rational numbers. Why? Rational because they got a ratio. They're fractions, right? 1.33 is not. 5 is not. 5 is a decimal, or 1.33 is a decimal, and 5 is a whole number. So you can't say rational are all fractions. That's not right. Why are they predictable? Because 1/2 will always give you what? If you divide 1/2, that will always give you what? 0.5. It will never change. You can bet your money on it. You can bet a $100 bill that whatever you punch into a calculator, if it's got the ratio of 1 to 2, your answer is going to be what? 0.5. Is there any doubt? No. What about 3/4? What's it always going to be? 0.75. No doubt. 5 over 1 is what? 5. There's no doubt. 4 over 2 is what? 2. There's no doubt. Why is this predictable? Because you know that next number is what? 3. Next number is 3. You know that without a shadow of a doubt. What's this? Well, numbers that are not predictable. Square root of 7. Get your calculators out. Square root of 2. I'll just pick out 3 numbers that are irrational. Okay, now somebody's got a calculator. Take the square root of 7 and give me that number. You're going to give me about 10 digits because your calculator only goes to 10 digits. Just go slow. Don't be saying 1.56352. I can't make it. All right, you got to go slow. What? Is that it? Okay, somebody tell me what that next number is. Anybody? Anybody will put a $100 bill on? You never know. You don't know. You don't know unless you actually calculate it. There's no prediction. There is no guarantee that this next number is 5. There is no guarantee that this next number is a 3. Where up here, you know the next number, you know this number, there is a location point. There is a distinct end to your number. Square root of 2. Somebody give me that number. 1.41. I'm sorry, 41? 42. 13. 56. 2. Anybody want to take a stab at that next number? You can't, because you don't know. And somebody give me pi. 3.141593. What is it? 3.149265. Anything else? Huh? 4. And somebody can maybe predict that next number. You can't. What in the world does this have to do with discrete and continuous? Same thing. If I was to give y'all, of course y'all can't see out the window here, but there is a fire hydrant right down there. The red fire hydrant. Just believe me, okay? There's a fire hydrant down there. And I bring in a box, a cardboard box of measuring utensils, measuring tools. What could they be? Well, it could be a yardstick, it could be a tape measure, it could be a carpenter's tape measure, it could be a digital tape measure, all different kinds. Maybe 5 or 6 different kinds. And I'd give y'all each a different type. Some of you may have the same type of tape measure. Some of you may have digital tape measure. Some of you may have some of you may not know what the carpenter's tape measure looks like, folding carpenter's tape measure. Some of you may have that. Some of you may have just a cloth tape measure. Some of you may have a 100-foot tape. Some of you may have a yardstick. And I send every one of you down to that at different times of the class. And you go down there, and I tell you to measure the height of that Fire hydrant. Okay? I tell you to measure the height of that fire hydrant. How many different, would we all get the same height? No, because half of it couldn't read tape. No, that's just not picking on y'all. That's just statistics. Half people that graduate high school cannot read tape measure. And we all know the Bishop's fault. It's not the school's fault. It's not the student's fault. It's the Bishop's fault. Okay? Half the students that come out of high school, half of y'all would guess and say, okay, that's 3 foot and there's 4 marks, 3.4. That's what y'all would do. And then half of you would read it somewhat correctly. But half of you would read different marks on the measure, and some of y'all would kick out around the mulch and measure where the metal actually hit the pipe, the water pipe that is sitting on it. So, what can you tell me? How many different measurements would I get? Well, there's 30 people in here. How many different measurements would I get? Probably 20. So, that would be continuous. Something that is, what is height? It's something that is what? Measured. Anything that is measured is going to be continuous. Why? Somebody tell me why. I just told you why. Because different readings. I can give y'all all the same tape measure. I can give y'all the same tape measure that reads digitally, and y'all would still give me different answers because of the way you're reading. Versus what? Well, first of all, it's measured. What are measured? What things are measured? I just told you one, height. Oops. What else? Weight. What else? Huh? Width. And well, all that good stuff. Anything that's measured. Anything. Height, weight. I always forget about one other one. There's another one. Just think of it. Okay? But, what's the opposite of measured? Well, what have I told you? What have I locked the gate of the entrance there and the entrance out here? Lock them. Close those gates. And I told y'all to go out and count the number of white cars, white vehicles in the parking lot. How many of you would come up with different lists? Well, some of y'all can count. But, most of y'all could count, and most of y'all would come in with the same number. Why? Because y'all would check 3 or 4 times to make sure that you counted all the white cars in the parking lot, and eventually y'all would come up with the same one. Counts. So when you're talking about rational, are you talking about discrete? You're talking about count. Discrete, I like to tell students to think of what? Concrete. In other words, if you go out there and count 20, if Mr. Murray goes out there and counts 25 vehicles, white vehicles, that means trucks and cars. Most of you, 90% of y'all will come up with 25 or 26 or 24, somewhere in there. Some of y'all might forget to count 1 or whatever. Some of you may be off by 1. But it's not going to be like the 15 different heights we're going to get of that fire hydrant. Now that's the difference between the two. Rational numbers is something that's predictable, something that has an end. What are discrete numbers? Discrete numbers are something that's counted. Continuous numbers or irrational numbers are numbers that cannot be located, or numbers that cannot be predicted. And height and weight, they're not discrete. They're continuous because Mr. Murray goes out there and measures the length of the height of that length. That's what I would say, length. Measures the height of that fire hydrant, and Mr. Vaughn goes out there, takes the tape measure from Mr. Murray, and goes down there and measures with the same exact, and he'll get a different measurement. Now, the off the 16th, he may measure to the quarters, he may measure to the 16th. It's going to be different. And somebody would just say, heck, 3 1/4, that's 3/4. You know, some people just round down to the nearest foot. So when you're talking about measurements, you're talking about something that's not predictable versus count, which is. And that's the best way that I can define or tell you the difference between discrete and continuous mathematics. Unless you just want to read the definition, then you're welcome to. Result when the data values are quantitative and the number of values is finite or countable. If there are infinitely many values, a collection of values is countable. It is possible to count them individually, such as the number of tosses of a coin before getting tails. That's the discrete side. And then continuous results from the infinitely many possible quantitative values where the collection of values is not countable. That is, impossible to count the individual items because at least some of them are continuous scales, such as lengths from 0 to 12 centimeters. Let me ask you a question. What if I asked you to measure the amount of liquid that's in that cup? If I told you, I'd have the stuff up here, and I told you to measure that I've got a cup up here and it's filled with some kind of liquid, and I told you to measure it. Well, I'm just telling you, is it discrete or continuous? I just told you the answer. Measure. Measure it is what? Continuous. And I told you to count the number of cups in this room. I just told you the answer. Count. It's what? Discrete. Now on the test, there's going to be 2 or 3 of these questions. And they ain't going to be mathematical. It's going to say count the number of blah, blah, blah. Measure the number of, and y'all will write the wrong answer. And it says measure, and it says count. And y'all will say the opposite. You'll say measure, oh, that's discrete. Count, that's continuous. I don't know what else to tell you. If it says measure, it means continuous. If it says count, it means discrete. So if you need to look over the video 2 or 3 times to remember that, do it. Please don't miss those on the test. Y'all will. But that's all I can tell you. Try not to miss them. Question, gripe, complaint. And like I said, some of y'all may remember that from Dango 120 or whatever y'all called it, probability and statistics in high school. Okay, I'm just going to show you the levels of, I don't go over these too much, but you might need to have them. They're on page 20, and they're at the bottom of page 20 right there. Make sure you make a note of them, just in case there's a question on the test, but I doubt they were on the homework. And they give you an example of each. Different levels of measurement. Ratio. Poor old Horatio. Ratios are measurements. Does it have anything to do with counting? Nope. So, ratios are usually going to be continuous. Ratios are continuous. Interval. It's measured. Body temperatures in degrees. Interval. Ordinal. That would be discrete. Why? Why would ordinal be discrete? Okay, people, think of order.
You're just arranging data.
You're arranging data in order. So technically, You're putting it in order. You're counting first, second, third, versus measurement of the first two. Ratio and interval, those are measurements. And nominal, eye color. Would that be discrete or continuous? Discrete, because you can't measure. Now, you could split hairs and say, well, there's light brown and then there's dark brown eyes. Okay, that's not for you to judge. All right? In this class, we're only talking a couple of eye colors. Brown, blue, and green. All right? We're not even going to discuss hazel. All right? Because that opens up for too much discussion. So in your case, in this introductory level, then nominal would be 3. Eye color, 3. Okay? Question. I don't know what that says. It says got an error. Okay, I think that's 1.4. I'm not sure. Let's see if it's 1.4 because I'm running into questions. No, that's 1.3. I think the syllabus says we go to 1.4. 1.4, page 23. Observational study versus an experiment. Basically, you need to know the difference between the two. An observational study, what does observe mean? You watch. Okay? You ever seen these sleep apnea videos where people are sleeping? Those are funny. All right? I don't want to see myself sleeping. But you watch these people sleeping, they look like they're going through convulsions. But is that observational or is that experiment? It's observational. You're just watching. Okay? What about the rat in the maze? Observation. What are you doing? You're observing the rat. Now, there could be a fine line there because you could put an extra piece of cheese in there, but I didn't say that. I said a rat in a maze. I didn't say anything about cheese. I said a rat in a maze. You're watching the rat in the maze. It's an observational. What about, and notice I'm not saying watching. Okay, watching is a dead giveaway. Giving half of you a pink pill and giving half of you a red pill, and the red pill and pink pill, I weigh y'all every Monday. And y'all take that pill every day, and I weigh y'all every Monday in class and see what happens. Is that observational or is that experiment? That's an experiment because I'm giving you something. I'm doing something to you to affect the outcome. One of them may be a placebo. The other one may be a secret diet pill that will revolutionize people losing weight. Okay? The whole point is I'm affecting the study because I'm giving half of you a placebo and I'm giving half of you a pill that will supposedly do something. That is an experiment. And you can do that. But that mindset, if I ask you to watch, or are you watching something, that is an observational study. If I'm asking you to take something or to do something, then that becomes an experiment. Do we use that very much? No, we do not. We're not going to get into experiments in this class very much. Most of yours is going to be observational, where you're looking at records or you're looking at past data or you're getting stuff from past data. So we're not going to be doing. But for for your research in your other classes, that's kind of important. Which one's which? Okay. And our cricket keeps chirping. I'm not going to go into simple random sample because that's a pain in the butt to explain. Alright, here we go. I want you to write down page 25. I want you to make sure you understand those different types of sampling. What is a random sample? Well, a random sample is when the key word on random sample, and you might want to highlight this because it's going to be on the test. I mean, if you get a multiple choice answer, this is going to be one of the multiple choice answers. It's somewhere in there where all objects have the same chance of being picked. Same chance of being picked. That's what you need to remember. I don't know if it's in there or not, but each person in this classroom has the same chance of being picked. And how is the only way to do that? Well, put all your names on a piece of paper and take those pieces of paper and put them in a what? A fishbowl. Or put everybody's name on this wall and have somebody throw a dart at this wall. Okay? That would be, I don't think that would be random, but they classify it as random because most people are going to throw in this area. If they're standing, right over there, they're not going to be throwing down here. So, who knows? Putting everybody's name on a sheet of paper and having somebody point blindly to a name. That would be a random sample. Make sure you understand what a systematic random sample is, right here. Picking every fourth person. So that would be going through and picking every fourth. You ever had a teacher divide the class up into groups by having people count off 1, 2, 3, 4, and then all the 3s get together and all the 4s sit together and all the 1s sit together? That's systematic random sample. Every third person, every fourth person. Convenient sample. Make a note. This is the most useless. Why is it the most useless? Well, it'd be like me hollering out the window right here to the Marlboro Club, "Hey, how many of y'all are smokers?" That would be all of them because they're all out there. All right. Having a survey on a radio station, what kind of music you listen to? Well, if you're listening to that station and it's a rock station, what are most of your people going to say? Rock? Classical? No, they're going to say rock because they're listening to the rock station. So a convenient sample is usually your least valid. Stratified sampling and cluster sampling. Stratified sampling would be something like an age bracket or gender. Where clusters would be kind of like Republican or Democrat. I'm sorry, that's accurate. Stratified would be Republican or Democrat. Yeah, I'm sorry. And stratified. Cluster sampling would be more like cluster sampling would be inside of a cluster inside of a cluster, which would be like a good example right there. In other words, they're surveying all the people in art history section 1 and biology section 2. They're not worried about gender. They're not worried about major. They're not worried about how old they are. They're not worried about their IQ because they're pulling out students from different courses and saying, "Are you in the Marlboro Club? Or are you driving a white car? Or how do you get to school every day?" And they're pulling out those people. Just make sure you know that for the first 3 or 4, we're not really too concerned about the last 2, but make sure you know the difference between a random sample and a systematic sample. Make sure you know the difference between retrospective, cross-sectional, and perspective. And there's the definitions right there. Retro when you hear the word retro, what do you think of? Old. In the past. Retro is in the past. Duh. Alright. Cross-sectional, that is one point in time. And then perspective would be something that's going to predict, something that's going to, tell us that if you think in the future, then you could think of in the future. Yes, it tells us what's going to happen, or what is the number of blah 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 that's going to be in 2020. That would be a perspective study. Cross-sectional would be, there were 17 wrecks this weekend due to drunk drivers. There was 25 wrecks 2 weeks ago by drunk drivers. How many do you predict for this next weekend? It's kind of perspective, but it's using perspective and it's using retro. Retro is saying, basically studying drunk drivers the past 2 years. Was it increasing or decreasing? Has the number increased or decreased in the past 2 years? It's staying with the retro. It's staying with it's not asking what is it going to do in the next year, or what did it increase or decrease over the last 5 years? That's the difference between retrospective and cross-section. And it gives you some more right there. I know this is just very exciting stuff, isn't it? At least I'm giving you the benefit of the doubt and going through and giving you some indicator of what's important. And that's 1.4, right? Is that what we go to, and then we go to chapter 2? Okay, so let's go to chapter 2. Make sure you write down these 5 things on page 44. Center, variation, distribution, outliers, and time. While y'all writing those down, I'll go ahead and uncluster the cluster that was last Wednesday. Math 120. Set of 20 for the 21st. Alright, now I do need it to be accurate, so I don't care if you wasn't here. Doesn't matter. It's not going to hurt you. I just need to know the truth, okay? Alright, Bailey. This was last week. Okay? Tell me if you were here, alright? Okay. You're lying. No, I'm just kidding. Bolt. You was here? Clayton was here. I remember her. Cowart. Okay. Dutchke, you were here, right? Are you lying to me? All right. Escobar. Farr. Freeman. Were you here the other day? Okay. Hammett. Harris. Harvey. Hayes. Johnson. Mullins. Murray, Newton, Poor, Perdesi. Okay, Robinson's. All y'all were here. Mahogany, you were here. Where's Mahogany? There she is. All right, Mahogany was here. I know the other two were here, even though he's not here today. He was here. Scarborough was here. Schuler, Simpkins, I'm going to give him the benefit of the doubt. Suidu, I know I didn't say that right. Sudu? Shidu. Yeah, you were here, right? Now remember, you were here. Smallwood, Vaughn, both of the Vaughns were here. Where's the other one? I don't see the other one. Were you here? You were here. Okay. Williams and Wood. Well, I guess everybody was here then. I'm going to give y'all the benefit of the doubt. I don't know. I don't know about that one. What did I say? Where is it? Schuler was here. Simpkins. I'm going to put no. Okay, that takes care of the cluster. I hope it took it this time. Alright, let me go back to today's. Y'all know this is the first Monday that y'all have actually been here? It sucks. Oh, me. Alright, Bailey, Bolt, Clayton, Cowart, Dutchke's here, Escobar, Farr, Freeman, Hammett, Harris, Harvey, Hayes, Johnson, Mullins, Murray's here, Newton, Poor, Perdesi, all the Robinsons except for Mr. Robinson's not here. Scarborough's here, Schuler, Simpkins, Shadut is here, Smallwood, Vaughn, both Vaughns are here, Williams, and Wood. Okay, everybody good? Everybody okay now? Let's make sure it, let's see, view attendance, make sure it did. Okay. That cricket getting on your nerves yet? Not making me fall asleep, making me go crazy. Alright. Now, basically, what these guys are doing here is setting you up for what we're going to get into in Chapter 3. Everything revolves around this guy. Everything revolves around that guy. And the most important part of this guy is what we call the center. That's the center. Variation. Variation is basically how wide the standard deviation is. If it's real tight, then it's going to be, there's hardly any variation. If there's a lot of variation, then these are going to be very wide, and so on. So the center is very important because the variation is based on the center. Okay. Inside two standard deviations is 95%. Write that down. Two standard deviations. Within two standard deviations, one standard deviation, two standard deviations. One standard deviation, two standard deviations. Alright? That's called normal. Within two standard deviations is called normal. Outside of two standard deviations to three standard deviations, right in here, this is called unusual. Right in here is called unusual. So that area right there is called unusual. Outside of 3 standard deviations is what's called an outlier. That's your 6'2" second grader. All right? Or your 300-pound third grader. Or your third grader that's got a 1600 SAT or 1800 SAT. That's your outliers. That's your people that they don't need to be in there because they need to be somewhere else because of what they're doing or what their problem is or whatever the case may be. So what they're doing here is getting you warmed up for this that's in chapter 3. It's called the Empirical Rule. I don't know when they show you that, but we'll get to that. And it's a very important page. It's called the Empirical Rule. Time, I don't go over time very much because most of y'all know what time is. Time is the thing that does not stop for anybody, does it? And this is one thing that you can always what? Predict. Why? Because it doesn't stop. It's the only thing that's constant. It's going to keep going no matter what. So I'm not going to go over time that much. I think most of y'all know what time is. So we're not going to go over that. Frequency distribution. Now, a lot of people, this is where your problems start because you don't understand what a frequency distribution is. And don't rely on that definition to help you out. Alright, let's say that I want to divide this class up, and let's say that I want on one side, I want to list y'all's names, and that's what I have. It's called a roll, right? And I list y'all's names. Anderson, Bates, Holmes. In other words, I list all y'all's names. I got about 30 names here. All right. Well, that's the way that most of your rolls are, right? Rolls are lists. And that's how you can list data. You can list data by listing the names. Or you can list them with a frequency distribution. And a frequency distribution is nothing but a head count. How many people in here have last name starts with A? Uh, 14. How many people in here I have start with B's? 2. How many people I have start with C? 4. And so on. Alright, it's a different way of accounting for a population or a sample. Okay? How many people in here are blonde? How many people in here are brunette? How many people in here are redhead? That's another way. I could make classes over here. The left side is usually going to be class. The right side is going to be head count. The head count is always going to be the head count. Now the classes may change. Brown eyes, blue eyes, green eyes, blonde, brunette, redhead, male, female. The classes can change, but the head count, how many is going to end up being in the room all the time? 30. No matter how you divide this up, it's going to be the same total no matter what. And that's what a frequency distribution is. A frequency distribution can be based on height. It can be based on age. It can be based on hair color. It can be based on eye color. It can be based on shoe size. It can be based on waist size. It can be based on anything. So make sure you understand that a frequency distribution is nothing but a head count with a what? Class. Now let's talk about this guy right here, table 2.2. Go ahead and write that down in your notes if you don't have a book. Up there in the right-hand corner, we're going to talk about those definitions right there in the yellow box. Alright, now this is going to take a lot of brain power here, okay? The lower class limits are right there. 50, 70, 90, 110, 130. Not that hard. That's your lower class limits. So if this is your lower class limits, what do you think the upper class limits are? 69, 89, 109, so on. Upper class limits. Well, I'm not going to insult your intelligence by going into too much lower class limits and upper class limits, because there they are. Anytime you have a field based on numbers, you're going to have a lower class limit and an upper class limit. Okay? Class boundaries. Class boundaries are right here. I'm going to take a green marker. That's your class boundaries. They're the numbers that are between 69 and 70, 89 and 90, 109 and 110, 129 and 130. There's a little rule that I like to tell students to remember here. If your classes are whole numbers, then you're going to use tenths. If your classes are tenths, you're going to use hundredths. If your classes are hundredths, you're going to use what? Thousandths, Hubert. That's right, class. If your numbers are thousandths, you're going to use what? 10 thousandths. That's the rule that is usually followed. Most of your classes are going to be whole numbers or tenths. But this one's whole numbers. So you're going to make your class boundary a tenth. Now what's between 69 and 70? That's it. Alright, now you could use 69.8. Why would you? I mean, you could. That would just be rough. Rough math. You could use 69.2 if you wanted to. Why would you? Use 69.5. Unless you just like, whips and chains and you like pain. Alright? Use 69.27 if you want to. That's just 69.5 is good. Great. Did I not just flip that page over? How did I sign out? How did I sign out? We all know whose fault it is. That's Bush's fault. Anybody know what page I was on? Thank you. I don't have to look it back up. 45. Okay, there we go. And of course, I'm going to have to move it back over. It's not going to. It's a conspiracy. That's close enough for government work. Let's see if I can move it around a little bit more. No, it's not going to let me. Well, that's close enough. All right. Huh? Oh, yeah, that's it. Thank you. There. All right. So if this was 50.1 to 69.1, then I would change my, since this is tenths, I would change it to hundredths and then so on. So, and we'll go over that when we go over some examples, because I'm not just going to show you this and I'm going to do examples, so don't worry about that. But just remember, if the classes are whole numbers, then you're going to use tenths. If the classes are tenths, you're going to use hundredths. If the classes are hundredths, you're going to use thousandths. If the classes are thousandths, you're going to use 10,000ths. So it's always one more off. And that's with the class boundaries. So the class boundaries for this one would be 49.5 to 69.5, 69.5 to 89.5, 89.5 to 109.5, 109.5 to 129.5, 129.5 to 149.5, and that's it. So that's not difficult. Class midpoints. Now these next two things are important. If I could ever get to them. There we go. Y'all supposed to have a heart attack because my phone went off. Sorry. All right. How's your teachers with your cell phones? How's that going? Have any freaks? Did they freak out? You did? Oh yeah, they're funny. I think you ought to start videoing them and putting them on YouTube. That's what I think. All right, class midpoints. This one's very important because this one is going to be used in your finding the mean and the standard deviation for a frequency distribution. So you need to put a star beside class midpoint. How do you find the class midpoint? Well, midpoint is equal to your lower class limit plus your upper class limit divided by 2. Just take your two class numbers, add them together, and divide by 2. Now the reason to find the midpoint is because in the problems that we're going to be doing, you cannot use 139 and 149. You can't say, okay, we're going to put 139 and 149 in an Excel spreadsheet, and we're going to use 139 and 149 in all our calculations. You can't use a range of 139 to 149 for a calculation. That's how many numbers? 19, 20, somewhere in there. You can't use 20 numbers in a calculation. You have to use one number. So what do you use? You use the midpoint. You find the midpoint between these two numbers. And that's the number that you use in your calculation. So this is very important that you learn how to do. Make sure you write that down because the midpoint is going to be very important for you. Class width. The class width is observed. You do not need, well, some of you might have to calculate it, but you shouldn't have to. I like to say, take your lower class limit and subtract your next lower class limit. That's what I like to tell students to do. So to find your class width, I'm going to take 70 and minus 20, or minus 50, or the 90 minus 70, or the 110 minus 90, or the 130 minus 110. What will we get no matter what we multiply? If we subtract those 70 minus 50, 90 minus 70, 110 minus 30. 130 minus 110. What will we get? 20. So your class width is 20. You can do it with the other side also. What is 89 minus 69? What is 109 minus 89? What is 129 minus 109? What is 149 minus 129? Subtract. Now, don't do it out of sequence. Don't say, okay, 90 minus 50 is 40, so the class width is 40. No, I didn't say anything like that. I told you, take this lower class limit, subtract that lower class limit. This one minus this one. This one minus this one. You could go horizontally, but I do not suggest that because people get confused. When I tell you to subtract 69 minus 50, what will you get? 19. Is that the class width? No, the class width is 20 because you got to include 50 because it's part of the class. But you don't. If you subtract, you get 69 minus 50 is 19, and that's wrong. So do not go horizontal unless you're going to include that number. So I would suggest use those two numbers right there. Okay? And that's your class width. So you should be able to find those. If you're asked on the homework, you should be able to find these 5 things. You should be able to find the lower class limits. And just to reiterate, I'm just going to go over it right quick. Hold on a second. This thing is being very persnickety. On the lower class limits, here's your lower class limits. Your upper class limits. So there's your lower class limits and your upper class limits. Your class boundaries are going to be in between those. And as I told you before, 49.5 to 69.5, 69.5 to 89.5, 89.5 to 109.5, 109.5 to 129.5, and 129.5 to 149.5. Midpoint. Well, let's go ahead and figure the midpoint for this one. Midpoint is 50 plus 69. Do not make fun of my mouse writing or you'll come up here and do it. Divided by 2. And that's going to be what? 70 plus 50 is what? 120. So that's going to be what? 119. Somebody check it for me. 119 over 2. Which is equal to what? 54.5. Is it 59? Okay. Oh yeah. 5 won't go in 11 twice. Okay, I'm sorry. All right, 59 what? Even? 0.5. And that's your class, that's your midpoint of your first class. Now, how do you find each one? You got to calculate each one? No. You take 59.5, and what did we say the class width was? 20, and you just add. 59.5 plus 20 would be what? 79.5. So that's your next one. 79.5 is right there. What's 79.5 plus 20? 99.5. What's 99.5 plus 20? 119.5, and so on. And of course, class width. Actually, class width should be above the class midpoints. That way you wouldn't have to calculate it. But anyway, it's not. So class width is going to be equal to 70 minus 50, which is what? 20. Mouse is running out of room. There we go. Question, gripe, complaint. I hope I'm not going too fast, but like I say, a lot of this will settle down after we start working on some problems. Class is over at 9:35, right? You kidding? 9:25? Oh well. Okay, where are we leaving off? What page? Page 45. All right. So right now, everybody is in. You're responsible from page to page 145, or to page.